So, hello boys, welcome to a new video. This is my first video in English in this channel. I'm gonna try to explain some three different types of alkyne, alkenes, alkynes. I'm gonna be much easy learning. So we're gonna talk about the first one, which is alkyne, and we're gonna talk about alkene and alkyne. We're gonna talk about alkyne, then we're gonna talk about alkene and alkyne. Each one of them has its specific properties, nickname. We can call it a nickname actually, because they have a nickname actually, and they have some sources. So we're gonna talk about these in a different ways, and all of them. First of all, we're gonna talk about alkyne. The alkyne is the simplest hydrocarbon, which is the most simplest one from alkyne and alkenes. Why? Because it is a saturated bond. The bond of carbon atoms are single. That means valencies of carbon atoms are saturated, like this one. Look at that one, baby. It's saturated because we have a carbon atoms and four hydrogens or four bonds of hydrogens, so it's saturated, so we don't need, so it is the simple one, which is gonna made as, or which is gonna give the name for the alkynes. And why it is simple? Because we call them paraffins, and paraffins mean, the para means less, and phens means reactivity or affinity. Reactivity, because they are less reactive, because they have a stable bond of carbon. So that's the first reason. So let's do it again. I don't want to explain that for you, because we're gonna take it in the physical properties actually, or yeah, in the physical properties. It is the simplest carbons that are the simplest hydrocarbon is alkyne, and the carbon atoms, they are single. That means valencies of carbon's atom is saturated, so it is saturated. That's important, boys. So we can call them paraffins, and para means less, and phens means reactivity. That's so much important to know, guys. So we're gonna go to the sources of alkynes and where we can get them. Actually, I'm not gonna talk about the preparation, because we need a special labs. So I'm not gonna take it here anyway. We need a lab, but we're gonna talk about the sources of alkynes. The sources of alkynes, actually, we have several sources of it, and they are, maybe we're gonna take here 6, but they are maybe more. But the first one and the most important one, the petroleum, because when we take the petroleum, a natural gas, from the underground surface of the planet, we're gonna push a water there, then we're gonna braise, we're gonna make the petroleum or the oil rise up, so we're gonna take it, and that is the first source of alkynes. Then we have the alkynes have a special thing actually either, which is it has the highest percent of natural gases, the methane. They are 85% of natural gas, which is the highest one. So you need to know that it has 85% of natural gas. That's so much important, guys. Sorry. And the alkynes are obtained commercially by the fractional distillation of a crude petroleum. We know the petroleum, we can take it, and the petroleum, it has a lot of benefits for us. One of it of the petroleum or the oil, the crude, is for maybe making in the fields of makeups, maybe in the fields of cars, everywhere actually. But it is so much important commercially. And marsh gas is formed by the bacterial decay of vegetable matter, contains mostly methane. In the marsh, I know all of you maybe know the marsh, even the people of Florida and the people in the south of Iraq. We have marshes, and this marsh, it has a lot of planets, and they live in the water, and you can see the marshes roots, the planet's roots actually in the water, and maybe in the underground, maybe in the ground. So it has a bacteria that will take maybe the resources from the planet, or maybe from the marsh itself, or maybe the water, and they gonna convert it, because they gonna take the benefits of these materials and drop the wastes maybe in the water. So it's gonna be like a bubbles from the water, and you know that is a methane, because the bacteria actually made it. 5. Fuel gases obtained from coal gas contains alkanes in small amounts. Actually, we don't have these kinds of heaters maybe, or ovens maybe in Arabs lands, but that actually form, and we can find it easily in Europe and United States. They have these furnaces, the big furnaces, which works on coal, and when we just start the fire up, they gonna burn. But these coals will give us a small amount, but actually that's maybe make a difference in the climate change. So don't light your coals, or actually don't light the furnace at all. Buy a heater, man. Buy a heater. And now, the 6 is methane occurs in gobar gas, switch gas, and biogas, which are formed by the decomposition of cattle, dung, excrete, and plant waste. Actually, the most animal that we have in these days is cows, because we're gonna have milk, meat, and even leather. But the only I think I have read a report that said the one cow can make maybe 5 tons of methane, uh, actually in the year. So it's gonna make a big difference in the climate change. I think the most, or the highest percent of cows are present in Spain, Netherlands, Saudi Arabia, UAE. I don't know about the other lands, but I know only these. So now we're gonna talk about physical properties of alkynes. So the alkynes form a homologous series of compounds. Listen, the first 4 members of series are gases. So every 4 carbons, they gonna be a liquid. Okay, I'm sorry, gases. I'm sorry, gases. But if we put another one up to maybe 10, they gonna be what? A liquid. But if we have more than 10, they gonna be a solid. So I'm just gonna take this off. So if we have 5 to 10 carbon atoms, they gonna make us what? A liquid. But the higher percent, or the higher members of this series will it's gonna be solids. So the first four, they're gonna be gas, and from 5 to 10 they're gonna be a liquid, and from 10 or up from 10 they're gonna be solid. So they are non-polar. Why? We know what is the polar and what is the non-polar. The non-polar, which is that water cannot dissolve in, but polar water can dissolve in. It's maybe I explained that in the previous series of this. I explained it in Arabic. Sorry. But they are non-polar, therefore they are insoluble in water. but soluble in organic solvents. So you have to memorize that well. Then they are non-polar, but they are insoluble in water. They cannot dissolve in water, but they can dissolve in organic solvents. Like what? Maybe like oil. Maybe that in oil they can dissolve there. So the density of alkanes increase gradually with the increase of molecular size. If you increase the molecular size of it, you're gonna increase the density of it. Like the density and molecular size, they're gonna be grow up, but the molecular size actually it's the main player here. It's the main character. And even the molecular size, the melting and boiling point of alkanes are increased regularly within the increase of molecular size. If you increase the molecular size, you're gonna increase the density and the melting and boiling point at the same time. This is because of an increase of attractive forces between the molecular of alkanes. We're gonna have a force between the molecular alkanes which gonna increase all of these three stuff. But we're gonna have something else increase with the molecular size, which is the viscous of their molecular size. If you increase the molecular size, the viscous will be increased as well. And they're gonna become less flammable, more difficult to burn with increase of the molecular size. So with the increasing of molecular size, we're gonna increase the density, we're gonna increase the melting and boiling point, and we're gonna increase the viscous and the flammable. We're gonna have less flammable. The flammability of the alkane will gonna be less. So all of these three stuff are important to memorize. Remember, boys, what just we explained here is about alkane, and in the next video we're gonna explain the alkyne and alkenes. But remember, all of these physical properties sources are for alkynes. Thank you for watching. See you in the next video. Goodbye.